Imagine being able to revisit the past or leap into the future at will. Could this ever be possible? Let's delve into the paradox of time travel. Time travel. It's a concept that has captured our collective imagination for centuries. It's been the cornerstone of countless science fiction stories, from H.G. Wells' groundbreaking novel The Time Machine to popular films like Back to the Future and Interstellar. But what is time travel really? At its core, it's the idea that we could move between different points in time as easily as we move between different points in space. However, when we start to consider the implications of time travel, things quickly become complicated. This is where paradoxes come into play. Paradoxes are situations or statements that defy logic or common sense, yet could theoretically occur if time travel were possible. Take, for instance, the grandfather paradox. This is a hypothetical scenario where someone travels back in time and unintentionally causes the death of their own grandfather before the birth of their parent. This would mean that the time traveler was never born. But if they were never born, how could they have gone back in time to cause their grandfather's death? Then there's the bootstrap paradox, which involves objects or information that exist without any discernible origin. Imagine you're a time traveler who goes back to the past with a book, which you then leave behind. That book is found by a young writer who copies it verbatim and publishes it. Years later, you buy this book and take it back in time with you. The question then is, who actually wrote the book? These paradoxes highlight the complex and often contradictory nature of time travel. They challenge our understanding of causality, the principle that cause precedes effect. If we can disrupt this sequence as time travel suggests, it throws our understanding of the universe into question. So, while time travel may seem enticing, these paradoxes present significant challenges to its feasibility. But don't lose hope just yet. As we'll see in the next scenes, science may still hold some answers for us. Stay tuned as we dive deeper into the fascinating world of time travel. If time travel were possible, how could it occur? Theoretical physics provides some interesting insights. Let's start with Einstein's theory of relativity, which is often the first stop on the journey towards understanding time travel. This theory, proposed by Albert Einstein in the early 20th century, essentially suggests that space and time are woven together into what we refer to as the space-time continuum. In this continuum, massive objects like stars and planets create a sort of dip or curve in space-time. This is what we experience as gravity. Now here's where it gets interesting. The theory of relativity also suggests that time isn't absolute but relative. It can speed up or slow down depending on the speed at which you're moving and the gravitational field you're in. Here's a thought experiment to illustrate this. If you were to place a clock on a spaceship and send it off at near light speed, time would slow down for the clock on the spaceship relative to a stationary clock back on Earth. This is known as time dilation, and it's been proven in numerous experiments. Now, if time can be stretched and squeezed like this, could it also be looped back on itself to allow for travel to the past? This is where the concept of wormholes comes into play. In theory, a wormhole is a shortcut through space-time, connecting two distant points like a cosmic bridge. If one could create or find a wormhole, and if it was stable enough to traverse, it could potentially provide a path not just through space, but through time as well. The idea of wormholes comes from the work of physicist John Archibald Wheeler and his colleagues in the mid-20th century. They proposed that wormholes could exist naturally at the quantum level, the subatomic realm of the universe where the laws of physics as we know them start to break down. However, there are significant challenges to the practicality of wormholes for time travel. First, we've never actually observed a wormhole, much less figured out how to create one. Second, even if wormholes do exist, keeping one open and stable enough for a human or a spaceship to pass through would likely require exotic forms of matter or energy that we don't yet understand or have access to. So, where does this leave us in the quest for time travel? Well, the theories of relativity and wormholes provide tantalizing hints that time travel could be possible, at least in theory. They suggest that time isn't a straight, unyielding line, but something more fluid and malleable. While these theories are fascinating, they remain purely theoretical and have yet to be proven. But who knows, Perhaps one day we'll find a way to turn these theories into reality and unlock the secrets of time travel. Until then, we'll have to satisfy our curiosity with the intriguing possibilities that theoretical physics presents us. When we venture into the quantum realm, the rules of time and space as we know them start to bend. In this mind-bending realm, particles can exist in multiple places at once, thanks to a phenomenon known as quantum superposition. Picture a particle that isn't just here or there, but both here and there simultaneously. Now, if we apply this concept to time, it suggests that an event could happen not just before or after another event, but both before and after simultaneously. This is a radical departure from our everyday understanding of time. But how could this allow for time travel, you might wonder? Well, if we could somehow harness the power of quantum superposition, it might be possible to exist in multiple times at once, effectively traveling to the past or future at will. Now, let's delve a little deeper. There's another quantum phenomenon that's worth mentioning here: quantum entanglement. This is where two particles become inextricably linked, such that the state of one particle immediately influences the state of the other, no matter how far apart they are. So, imagine if we could entangle particles across time, not just space. This could potentially allow for instantaneous communication across vast temporal distances. Send a message to the past or receive one from the future, perhaps. It's a tantalizing thought, isn't it? But before we get too carried away, it's worth noting that these are highly theoretical concepts. We're still in the early stages of understanding the quantum realm, and there are many challenges to overcome before we can even think about putting these ideas into practice. We don't yet have a quantum theory of gravity, for instance, which is crucial for understanding how time behaves at the quantum level. Quantum physics provides a tantalizing glimpse into the possibilities of time travel, but there's still a lot we don't understand about this mysterious realm. Indeed, the quantum world is a strange and fascinating place, where the future could potentially influence the past and vice versa. However, the journey to unravel its secrets is just beginning. What does the future hold for time travel? Are we any closer to making this sci-fi dream a reality? As we peer into the future, the concept of time travel continues to captivate scientists, theorists, and dreamers alike. With each passing day, we inch closer to the precipice of understanding, unraveling the mysteries of time. In the realm of cutting-edge research, scientists are exploring the concept of wormholes, cosmic shortcuts that could theoretically allow for faster-than-light travel. The idea comes from Einstein's theory of general relativity, which suggests that these tunnels through space-time could exist, yet they remain purely theoretical, as we've yet to detect a wormhole in the cosmos. But imagine, if we could harness these cosmic bridges, we might one day glide through time as easily as we sail across the sea. Parallel to this, quantum physics is also offering intriguing avenues for exploration. Quantum entanglement, a phenomenon where particles become interconnected regardless of distance, could potentially be used to transmit information across time. Yet this too remains largely speculative and unproven. The quantum world is a strange one, operating under rules that defy common sense. But if we can decipher its cryptic language, who knows what possibilities could unfold? As exciting as these prospects are, they also raise numerous ethical considerations. If time travel were possible, what would prevent us from meddling with the past or foreseeing the future? Could we handle the responsibility that comes with such power? These are questions we must grapple with as we push the boundaries of our understanding. While these scientific investigations are ongoing, we must remember that time travel, for now, remains the stuff of science fiction. We are yet on the cusp of turning the pages of theoretical physics into tangible reality. But as we venture further into the uncharted territories of science and technology, we continue to challenge the limits of what's possible. Time travel remains a captivating concept, but it's still firmly in the realm of science fiction. But who knows what the future may hold? Time travel, a fascinating concept filled with paradoxes, theoretical possibilities, and many unanswered questions. We've delved into the mind-bending paradoxes that time travel presents, the grandfather's paradox and bootstrap paradox standing as prime examples. We've explored the realm of theoretical science, where Einstein's theories of relativity open up the possibility of time dilation and wormholes. we've journeyed into the mysterious quantum realm, where particles seemingly exist in multiple places and times, hinting at the potential for quantum teleportation and maybe, just maybe, time travel. And we've pondered the future of time travel, acknowledging the ongoing and relentless research into this tantalizing prospect. Yet, we must remember, these are theories, possibilities, not certainties. Whether or not time travel will ever become a reality remains to be seen. But one thing's for sure, it's a fascinating subject that continues to captivate scientists and laypeople alike.